In this video, we will learn how to use some of the basic integration formulas. In the previous video, I taught you what integration means. So if you did not watch the previous video yet, you should watch that first, and I'll try to put a link up here in this area somewhere. But here are the first few basic integration formulas that I want you to be familiar with. So the integral of 0 is just the constant of integration. The integral of a constant is that constant times x, of course, plus the constant of integration. So, for example, if I did the integral of 3 dx, that would be 3x plus c. All right? Now, this third rule tells us that if we have the integral of a function that has a constant in the front, you can take the constant outside of the integral and then perform the integral on the remaining function. The fourth rule is very important. It tells us that, like differentiation, integration can be separated by addition and subtraction. So if you have a function that can be thought of as the sum or difference of two or more functions, you can simply take the integral of each part separately. In the previous video, we derived this final formula, which is the power rule for integration. This is going to be tremendously important because, for example, if I have the integral of, let's say, x to the third power dx, to find this antiderivative, I will simply increase the power by 1, so that will be x to the fourth power, and then I will divide by that power. So x to the fourth power divided by 4, and of course we have to add the constant of integration. This is going to come up a lot. You might want to pause your screen and write down this list of basic integration rules relating to trigonometry. Of course, these are the mirror images of the differentiation rules that we learned in a previous unit. And ultimately, you want to memorize these. But for now, you can look back at your list and refer to them as we practice some basic integration techniques. Example 1, find the antiderivative of 3x. Well, we have a constant of 3 in the front. We've just learned that you can pull a constant outside of the integral before you get started. So we can take the integral of x dx. This is ready for the power rule. This is x to the first power. So the power rule of integration says we can add 1 to the exponent. That will give us x squared. And then divide by that new power. So that will be the integral. Of course, we have to add the constant of integration. So this is the integral of x. And we still have this constant of 3 out front. When you distribute the 3 times this constant would really be 3c. So normally, we would do something like this. We would have 3x squared over 2 plus 3c. But this constant of integration is a generic constant. It could be any constant. So multiplying by 3 doesn't change that. So there's really no need to have this 3. 3 times some random constant is still a random constant. So we don't have to include the 3. We will just put c as the constant of integration. All right, let's find the integral of 1 over x to the third power dx. First, let's rewrite this. 1 over x to the third power would be the same thing as x to the negative 3 power. So in this form, we can easily apply the power rule. We will increase the exponent by 1, so we will add 1. This will become x to the negative 2 power. And then you divide by that new power. So this will be x to the negative 2 power divided by negative 2. Let's go ahead and include our constant of integration. Now we will just simplify this. X to the negative 2 power, that will drop down to the denominator, and then we will have 1 over negative 2x squared plus c. So this will be the antiderivative, or the integral. I'd like to go back and check our first two answers, just to remind you what an antiderivative is. I'm not going to check all of the answers, but let's check these first two. Remember that an antiderivative is something that will give you the original function back if you take the derivative. So if we take the derivative of this answer, it should give us 3x. Let's check. So let's take the derivative of our answer. And see if we get 3x back again. So first of all, we have the power rule. So if I take the derivative of 3 over 2x squared, I'm going to leave the 3 over 2 alone for a minute. But the power rule, I'm going to take this 2 and put it in the front. And then I'm going to decrease by 1. So the 2 goes in the front, and I'm left with x. So I have this. When I take the derivative of a constant, that is 0, so I write nothing. On the next move, these 2's will cancel each other out, and that will leave me with 3x. So we got the original function back when we took the derivative. That proves that this is, in fact, the antiderivative. Let's check our answer to example 2 as well. If we take the derivative of this, it should give us 1 over x to the third power. Let's check it out. So we're going to take the derivative of 1 over negative 2x squared plus c. To do this derivative, I think we should change the form a little bit. So let's take the derivative of negative 1/2 x to the negative 2 power plus c. So now we are ready to do the power rule. So the power rule for differentiation says we will take this negative 2 and put it in the front. So I'm going to leave the constant alone like we do. And then here comes the negative 2 in the front. But then we are to decrease the power by 1. So this will be x to the negative 3 power. Of course, the derivative of a constant is 0, so I write nothing. Notice that, again, these are going to cancel. Negative 2 times negative 1/2 is positive 1. So basically, these cancel each other out. So that leaves me with x to the negative 3 power, which, of course, is the same thing as 1 over x to the third power. So, because taking the derivative gives us the original function back, that proves that this is the antiderivative. Example 3, let's find the integral of the square root of x dx. Let's rewrite the square root of x as x to the 1/2 power. Now we can easily do the power rule. So remember, the power rule for integration is that we will increase this by 1. So that will give us x to the 3 over 2 power, right? Because 1/2 plus 1 is the same as 1/2 plus 2 over 2. That's 3 over 2. So we're adding 1, and then you divide by that new power. So I will have x to the 3 over 2 power divided by 3 over 2. And of course, we must include the constant of integration. Dividing by a fraction, you multiply by the reciprocal. So we're going to wind up with 2/3 x to the 3 over 2 power plus c. And that's it. This is the integral of the square root of x dx. Let's find the integral of 2 sine x dx. So we have learned that you can move the constant outside of the integral. So that's going to give us 2 and then the integral of sine x dx. So we will keep the 2 out in the front as we do our integral. And one of the things that we will have to memorize is that the integral of sine x is negative cosine x. So we will now have negative cosine x plus the constant of integration, of course. And when we multiply by the 2, we will have negative 2 cosine x. And remember that when you multiply 2 times this general constant, we will still just leave it as a general constant. But this will be the antiderivative. Here is a strange looking little integral. It looks like we have the integral of nothing. But really, this is the same thing as saying the integral of 1 dx. And one of the things that we have now memorized is that if you take the integral of a constant, then you're just going to have that constant times x. So this is going to give us x plus the constant of integration, of course. So very simple, but something that you need to be aware of. When you take the integral of a sum, we can take the integral of each part separately. So first of all, the integral of x, we're using the power rule where we increase the exponent by 1, so we have x squared, and then we divide by that new power. So that's the integral of the first term. Moving on to the 2, the integral of 2 is 2x. And then in each case we'd have a constant of integration, but we will combine those into one overall constant of integration. So this is the antiderivative of x plus 2. So let's take the antiderivative of this polynomial. We just have to integrate each term separately. So as we integrate the first term, we're going to have the 3, which will stay out front. Then we will use the power rule of integration for x to the 4th power. So we increase the exponent by 1, which will give us x to the 5th power, and then we divide by that power. Moving on to the second term, the negative 5 will just remain out in the front. Now here comes the power rule. Increase the exponent by 1, and then divide by that power. Finally, we get to the x, and we're still going to use the power rule. Increasing the power by 1 will give us x squared, and then we divide by that power. And of course, in the end, we need to add the constant of integration. We can clean this up a little bit by writing 3/5 x to the 5th power minus 5/3 x to the 3rd power plus 1/2 x squared plus c. As we find the antiderivative for example 8, the best thing to do would be to rewrite the problem so that we will divide the x and the 1 individually by the square root of x. So this would be the same thing as having x over the square root of x plus 1 over the square root of x. So let's rewrite each one of these fractions. So remember that the square root of x is the same thing as x to the 1/2 power. So I have this. Now, when you divide with variables, you subtract the exponents. So I have 1 minus 1/2. So this is going to be x to the 1/2 power, because 1 minus 1/2 is 1/2. For the next fraction, 1 over x to the 1/2 power is the same thing as x to the negative 1/2 power. So when you integrate and you have a sum, you can find the integral of each term separately. So for the integral of x to the 1/2 power, we're just going to use the integration power rule, where we add 1 to this exponent. So 1/2 plus 1 is 3 over 2. So we're going to have x to the 3 over 2 power. And again, that's because 1/2 plus 1 is the same thing as 1/2 plus 2 over 2, which is 3 over 2. Then you divide by that new exponent that you just found. So I will have 3 over 2 in the denominator as well. So we've integrated that. Let's also do the power rule on the next one. I'm going to again add 1 to the exponent. So that will make this x to the 1/2 power. Negative 1/2 plus 1 is positive 1/2. And then you take that brand new power that you just found and you put that in the denominator. In the end, we will need a big old constant of integration. When you divide by a fraction, you multiply by the reciprocal. So this will become 2/3 times x to the 3/2 power plus 2 times x to the 1/2 power plus c. Again, we're just taking these denominators and we're multiplying by the reciprocal. So that's the answer. This is the antiderivative. Now, the original problem had radicals in it, so let's find a form that has radicals in the final answer. Also, let's pull a common factor outside of parentheses and leave that in the front. So for the numerical part, I'm going to just choose the leading coefficient of 2/3. So I'm definitely going to bring that outside the parentheses. When it comes to the variable, I'm going to choose the smallest power. So I have x to the 1/2 power is the smallest. So I'm going to bring out 2/3 and x to the 1/2 power outside of parentheses. So I'm really just doing this part because I'm still going to leave my constant of integration out front. So to figure out what goes inside the parentheses, I need to divide both terms by this GCF that I've pulled out. So I'm going to take this and I'm going to divide by 2/3 and I'm going to divide by x to the 1/2 power. And I will do the same thing here, dividing by 2/3 and dividing by x to the 1/2 power. So of course, the 2/3 cancels out right here. So that's gone as far as what goes inside of the parentheses here. But then we have 3/2 minus 1/2. Okay, 3/2 minus 1/2 is 2/2, which is simply 1. So this is going to leave simply x inside the parentheses. Now for the second term. So first of all, I need to divide 2 by 2/3. So I've got this 2 divided by 2/3. If I multiply by the reciprocal, this would be the same thing as 2 times 3 over 2. But look, those 2's are going to cancel each other out. So I'm going to end up with a 3. So I'm going to have a big old 3 right here. Of course, we have x to the 1/2 power divided by x to the 1/2 power. Those simply cancel each other out. And we have only the 3. So if we take out this common factor outside of the parentheses, this is what we are left with inside the parentheses. Now, as promised, let's put the radical back into this. So this will be the same thing as having 2/3, and then the square root of x, and then x plus 3 in parentheses. And don't forget the constant of integration. So this is another form of the answer, and probably this is the best form. If you start off with radicals in the answer, your final answer should be back in radical form. And it's a good idea to factor out the GCF whenever possible.